Hello, this is part 2 of derivative practice problems part 2. And if for any reason you forgot how to differentiate using certain techniques, go ahead and check out my videos on differentiating. So on number 1, it says find, so for all these problems, it says we have to simplify. So number 1 says find f prime of x if f of x equals 4x cubed minus 3x squared all over 5x to the 7 plus 1. So I've started this already, and f is this. I'm going to use, to find the derivative of this, I have to use the quotient rule, which is f prime of g minus g prime of f all over g squared. So f is 4x cubed minus 3x squared, f prime is 12x squared minus 6x, and then g is 5x to the 7 plus 1, and g prime is going to be 35x to the 6. So if we just put it in the formula, it would be 12x, f prime is 12x squared minus 6x times 5x to the 7 plus 1 minus g prime, which is 35x to the 6 times regular f, which is 4x cubed minus 3x squared all over g squared, which is 5x to the 7th plus 1 to the square. So when you simplify the numerator and FOIL out that minus, your final answer should be this. I'm not going to go too much on details, because you should know this in algebra to know how to FOIL and collect by terms. So on the numerator, when you simplify the numerator, it's just going to be negative 8x to the 9 plus 75 x to the 8th plus 12x squared minus 6x all over 5x to the 7th plus 1 squared. Try two. So just look at number 2 and see, go ahead and press pause or okay, so on 2 it says find f prime of f prime of x if f of x equals x cubed minus 4x plus 3 times x plus 1. So how are we going to find f prime of x? We're going to use product rule. So if you recall, product rule is this: f prime of g plus g prime of f. So we know our f is going to be x squared minus 4x plus 3. And then f prime is going to be 2x minus 4. And g is going to be x plus 1. So g prime would be 1, because the derivative of x is 1 and then derivative of 1 is 0. So just use the product formula, and so f prime of x is going to be f prime, which is 2x minus 4 times x plus 1 plus g prime, which is 1 times x squared minus 4x plus 3. And then this is going to be, when you FOIL this out, this is going to be 2x squared plus 2x minus 4x minus 4 plus x squared minus 4x plus 3. And then FOIL it out. It's going to be 3 x squared minus 6x minus 1. Okay, number 3 says find f prime of x if f of x equals 8 square root of x to the fourth minus 4x to the second. So how would I take the derivative of this? I would use power rule and chain rule. First off, I would rewrite, to make it easier, I would rewrite this as 8 parentheses x to the fourth minus 4x to the second, raise it to the 1/2. And then just take the derivative of this. So you have to use the power rule. So f prime of x equals, so 8 times 1/2 is going to be 4. And then you just leave the inside. Now we so this stays the same inside. And then the power is going to be 1/2 minus 2 over 2. So 1 minus 2 is negative 1 over 2. And then you take the derivative of the inside. So the derivative of x to the fourth minus 4x squared is going to be 4x cubed minus 8x. And let's see. So when you simplify this, well, you could put this negative power as a positive. So it's like saying 4 times 1 over x fourth minus 4x squared to the 1/2. And then times it by 4x cubed minus 8x. So when you fill out the 4, this is going to be 16x cubed minus 32x over, now x to the fourth minus 4x squared raised to the 1/2, that's equivalent to saying square root of x fourth minus 4x squared, right? Then what you're going to do is, could we, on the numerator, could we take anything out? And the same thing with the denominator. I think so. We could take out let's take out 1x. So on the numerator, you could take out 1x. So this would be 16x squared minus 32 over, and then over here, you can take out I can take out an x squared. So it's still inside the radical. So this would be x squared minus 4. And we know that the square root of x squared is going to be x, or actually, yeah. So you can take, so the x squared is the same thing as x times x, which you can take out. So what I'm saying is square root of x squared is the same thing as x. So you could take it out. So it would be like x parentheses x squared minus 4. And then you can take out, cancel with x. So this is going to be, your final answer will be f prime of x equals to 16x squared and then you're still left with inside the radical, you're still left with square root x squared minus 4. Is your final answer. Okay. Number 4, find f prime of x if f of x equals x over x squared plus 1 raised to the third. How would I do this? How would I find f prime of x? So I would definitely use chain rule and quotient rule. So f prime of x is going to be, so first I'll apply the power rule. So this would be 3 parentheses x over x squared plus 1 to the second times the derivative of the inside, right? So how do you take the derivative of x over x squared plus 1? Simple, right? It's quotient rule. So f is x, so f prime would be 1, and then g is x squared plus 1, and then g prime is going to be 2x. So if you apply the quotient rule, it's going to be x squared plus 1 minus 2x squared all over g squared. So it's going to be x squared plus 1 squared. Okay. So what can you do? So let's simplify the left. So if we square x over x squared plus 1, that's equivalent to saying x on the numerator would be x squared plus, then you have to distribute this from 3. So that's going to be 3x squared. And then on the bottom, x squared plus 1 squared is going to be x squared plus 1 squared. I'm not going to FOIL it out. And times, and then we'll simplify this fraction. So x squared minus 2x squared is negative x squared. And then x squared plus 1 squared. So this is going to be 3x squared minus x squared is minus 3x to the 4th. And then this is going to be x squared plus 1 squared times x squared plus 1 squared is going to be x squared plus 1 to the 4th. So this is your final answer. Let's move on to number 5. So find f prime of x if f of x equals the 4th root of 2x minus 5 all over 5x plus 2. So how would I, what rule would I use? I would use logarithmic differentiation. So if you forgot how to do logarithmic differentiation, go ahead and check out my video on logarithmic differentiation. So first I would rewrite, I would rewrite this as a power. So I can rewrite this as f of x equals parentheses 2x minus 5 all over 5x plus 2. Raise it to the 1/4. Yeah, so I definitely will do logarithmic differentiation. I could definitely use the power rule and then the quotient rule, but let's try something different. So, well, okay, so maybe if I, instead of using f of x is the same thing as y, so maybe I'll just call this y for right now. And then, so the first rule of logarithmic differentiation is like, take the ln of both sides. So on the left side, it's going to be ln of y. And then on the right side, before I take the ln, I'm going to use my log rule. So this is all raised to the 1/4. So it's going to be 1/4 ln numerator, which is 2x minus 5. And then we are dividing logs. So when you're dividing logs, you're really subtracting. So it's going to be minus. And then this 1/4 is still there because it's everywhere. Hold on, wait, how about this? I think I went too fast. Let's just do it step by step. So this would be using your log rule, it would be 1/4 bracket ln of 2x minus 5 all over 5x plus 2. And then when you expand it, so this is going to be 1/4 ln of 2x minus 5. When you're dividing rows, subtracting, so it's minus 1/4 ln of 5x plus 2. And then over here, this is going to be ln of y. And go ahead and take the derivative. So the derivative ln of y is 1 over y times. So it's kind of like implicit differentiation. So 1 over derivative ln of y is 1 over y because it has a y in it. It's going to do a y prime, or f prime of x, the same thing. How about, yeah, let's call that f prime of x. So over here, this is going to be 1/4 times the derivative of ln of 2x minus 5 is 1 over 2x minus 5 times the derivative of 2x minus 5 is 2. And over here, this is going to be 1/4 times 1 over 5x plus 2 times the derivative of 5x plus 2 is going to be 5, right? Okay, so this is going to be, so 1/4 times, that's going to be, well, the 2 and the 4 can be reduced. Let's do that so that this will become a 1 and then this will become a 2. So this is going to be 1 over 2 times 2x minus 5 minus, this is going to be 5 over 4 times 5x plus 2. And then this is going to be 1 over y times f prime of x. So before I get rid of this 1 over y by multiplying both sides by y, let's simplify this side right here. So you're subtracting fractions. So when subtracting fractions, you do need a common denominator. So what would be my common denominator? It would be this times, so we have a 2 and a 4, so it would be 4, right? So your common denominator would be 4 times 5x plus 2 times 2x minus 5, right? So over here, what are we missing? So this is our common denominator. So we're missing a 2. So we're going to multiply top and bottom by 2. What else? A 5x. We're also missing a 5x plus 2. Okay, over here, what are we missing? We have a 4 and we have a 5x plus 2. So we only need a 2x minus 5. So this is going to be 2 times 5x, that's 10x, plus 4 minus, so FOIL this out, this would be 10x minus 25, and then FOIL out this minus, so that's negative 10x plus 25 over, and then over the common denominator, which is 4 times 5x plus 2 times 2x minus 5. So over here we have 1 over y times f prime of x. So I think we should do is solve for f prime of x. So to get rid of this 1 over y, we're going to have to multiply both sides by y. So this is just going to be f prime of x equals to y bracket. And then I guess we can simplify this so this cancels. So we're left with 25 plus 4 is 29. And then on the bottom, we're left with 4 times 5x plus 2 times 2x minus 5. Okay, and then I guess you can, the last step would be replace y with our original problem. So what was our y? It was this whole thing. So I guess you could say, oh, wait, this is one, we have a 4 here, so that is I could just take that out. So that's equal to saying 1/4. So it'd be like 1/4 times our original y, which is 2x minus 5 all over 5x plus 2 raise it to the 1/4, because it's the same. So this is equal to, this right here is equal to saying the 4th root of this, right? And then it's times it by 29 over 5x plus 2 times 2x minus 5. And then what can you do? You can you can leave your answer like this. This is okay. If you want to be like really super clean about this, you can simplify it, and your final answer can also be expressed as this. So this would be your final answer. Number 6, find f prime of x if f of x equals the square root of x squared plus 1 over x squared minus 1. So on 6, it's just like number number 5. Yes, number 6 is just like number 5. You can either do power. You can write. Well, first off, I'm going to write it as a power. And then what I'm going to do is use logarithmic differentiation. I will not use power rule. I mean, I will not use, you could use power rule and chain rule, but I just think it's more efficient to use log rule. So it's going to be, so you could say f of x, same thing as y equals. So this would be expressed as so take the ln of both sides, so ln of y equals, and then use your property of logs. So this would be, when you have a power, it's going to be 1/2 ln of x squared plus 1 over x squared minus 1, right? And then use your property of log. So we do, so this would be 1/2 ln parentheses x squared plus 1. And when you're dividing logs, you're really subtracting, so it's going to be minus. And then do not forget about this 1/2 because it's boiled out. So it'd be 1/2 and then ln of x squared minus 1. And then take the derivative. So over here at the left side, you do have to like, it's kind of like implicit differentiation. So it's like saying 1 over y. So the derivative ln of y is 1 over y plus there's a y. So you have to do y prime. And this is going to be the derivative of this whole thing. It's going to be 1/2. And then the derivative of this is going to be 1 times, 1 over whatever this is, times the derivative of x squared plus 1, which is 2x. Okay. And then it's going to be a minus 1/2 times 1 over x squared minus 1 times the derivative of x squared minus 1 is 2x. So over here, what cancels the 2? So you're just left with x over x squared plus 1. Over here, what cancels, I think the 2's, so you're left with minus x over x squared minus 1. Wait. Oh, yes, now, okay. These do not cancel because what do you have to do when you're subtracting fraction? You need a common denominator. So if you look at our denominator, we have an x squared plus 1. Over here, we have x squared minus 1. So what would be my common denominator? It would be x squared plus 1 times x squared minus 1. So yes, so go ahead and simplify. So this one is missing an x squared minus 1. And then over here, x squared minus 1, you are missing a x squared plus 1. Okay. And when you FOIL this out, x squared times x is x cubed minus 1x. And then x squared times x is x cubed plus x. And then you do have to FOIL this minus, so it's going to be minus x cubed minus x. And then on the bottom, it's just x squared minus 1. So, and then it's just the common denominator, right? Okay, so on the numerator, the x cubes cancels, and then you're left with negative 1x minus 1 is negative 2x. And on the bottom, you're left with x squared minus 1 times x squared plus 1. And then over here, it's just 1 over y times y prime. Okay, and then to find y prime, or the same thing as f prime of x, you have to get rid of this 1 over y by multiplying both sides by y. So it's going to be y prime equals to y times this whole thing, right? And then I guess if you want, you can replace y prime is the same thing as f prime of x, if you want to call that. And then our y is the original problem, which is you can just write it out as the original one. So it'd be square root of x squared plus 1 over x squared minus 1 times this thing, right? So this is perfectly fine. This answer is perfectly fine. If you want to simplify, like using only powers, you can. It would be simplified as negative 2x Okay, so this could also be your final answer. So this answer is fine, and this answer is fine. Okay, let's move on to number 7. Find f prime of x at x equals 1 if f of x equals x fourth minus x squared times 2x cubed plus 1 plus x. So remember, a derivative is technically a number. So remember, your slope, here's your tangent, right? I mean, sure, you'll have an equation, but the actual slope of this equation is a number, like it could be 2. So that's why don't be alarmed if your final answer is just going to be a constant or a number. Okay, so let's first find f prime of x. So to find f prime vector, definitely use product rule. So this is going to be 4x cubed minus 2x, and then g is going to be 2x cubed plus x, and then g prime is going to be 2 times 3 is 6x plus 1. Okay, so go ahead, let's try. So f prime of x is going to be this 4x cubed minus 2x times 2x cubed plus x plus parentheses 6x squared plus 1 times x to the fourth minus x squared. So you don't have to FOIL it out and collect like terms. What I would just do is substitute the one value, the x value of f prime of 1 immediately. So this would be 4 times 1 cubed minus 2 times 1, 2 times 1 cubed plus 1 plus 6 times 1 squared plus 1, 1 to the fourth minus 1 square, and this would be 4 minus 2, and then this would be 2 plus 1 plus 0, and 4 minus 2 is 2, 2 plus 1 is 3, and then plus 0, so your final answer would be 6. So f prime of the x value of 1, it gives you a slope of 6. Okay. Let's move on to the last one. So it says find dy dx if y equals u squared minus 1 and u equals 1 over x minus 1. So this sounds kind of weird. Just recall that to find dy dx, you need to do dy over du times du over dx. So you can see the du cancels, so you're left with dy over dx. So first, let's find dy over du. So it's from here. So you're taking the derivative in respect to u. So dy over du is going to be 2u, and then the derivative of -1 is 0. You could put a d, so in respect to u, so this does have a u, so it would be like du over du. So you don't have to, that's why this cancels. So that's why it's just 2u. And then let's find the derivative of du over dx. Let me put it here, du over dx. You do have to take so this is like taking the derivative in respect to x. You do have to use the quotient rule. So actually, no, I won't. I don't have to use the quotient rule. What I would do is use power rule, because 1 over x minus 1 is the same thing as x minus 1 raised to the -1, right? So if you take the derivative of this using power rule, it would be -1 times x minus 1 to the -2, right? Power rule, times the derivative of the inside, which is 1. And then if because we are taking the derivative in respect to x, it is going to be dx over dx. So the dx over dx cancels. So when you simplify this, this is going to be -1 over x minus 1 squared. Okay. So dy over dx is dy over du, which is, what did we say dy over du is? It is 2u times du over dx, which is -1 over x minus 1 squared. And finally, when so it's 2, and then what did we have to, they said to substitute u with 1 over x minus 1. So that's like saying 2 times 1 over x minus 1 times -1 over x minus 1 squared. So 2 times 1 times -1 is -2. And then x1, that's like x minus 1 cubed. So that's going to be dy over dx. Okay, that's it. Yeah, that's it for this section. Thank you. Have a good day. Bye-bye.